Now, if your B is again the 2, 7 vector, and we also refer to that as the bracket X vector, and your basis is 1, 2, negative 1, 1, which is different than the basis we saw before, then actually, no, that is the basis we saw before. Then, working it out in detail, your X representation with respect to the script B basis is going to be the inverse of this matrix, which is the matrix of columns here. Columns being your basis vectors, multiplied by that vector, the inverse of this matrix. That's your A inverse times your column vector. Column vector could be called bracket X, could be called B, column of numbers. Okay, well, we invert this matrix, and I won't say it's embarrassing. It's really kind of, I probably ought to do a video on what was going through my head as I was trying to invert this matrix. Because I did the right thing and multiplied it out, and it didn't work, didn't appear to work, because I just wasn't thinking about one really simple thing, and then I went into all kinds of gyrations. Hopefully somebody got a good laugh out of that, because it deserved one. Anyhow, the inverse of this matrix is obtained by just changing the sign on the diagonal. At the non-main diagonal, what's the word for non-main diagonal? Secondary diagonal. And that only works for 2 by 2 matrices. So anyhow, here's the inverse. Okay, and it might be a little hard to read. 1/3, 1/3, negative 2/3, 1/3. Okay, just changing the signs on that secondary diagonal. Okay, we multiply this by 2, 7, we get 3, 1. And that tells me that the representation of this X vector here, in terms of the basis script B, is 3, 1. And of course, 3, 1 with respect to this basis means 3 times your first basis vector plus 1 times your second basis vector. So 3 times your first basis vector, that's here. 1 times your second basis vector is here. If I add, do the multiplication and add these, I get my 2, 7. I get my original column. So that verifies that this is the correct representation of this vector with respect to this basis, and it verifies this process of forming the matrix that's the inverse of your of the matrix you get when your basis vectors are your columns, and then converting that, multiplying it by your actual vector, by your vector in standard notation. Okay, well now if we have a second basis, B prime, we can do the same thing. Now this matrix is really easy to invert, lucky for me, okay? We form the matrix, we multiply the inverse by the 2, 7 vector for all the reasons that we developed at the beginning here in the first video. And we call this matrix A hat. Okay, now this isn't the notation your text uses. Your text uses P matrices. Of course, when you have 2 bases, if you want to do it, you can't use P for both of them. So maybe you'd use P hat. In any case, there it is. Okay, so there's your inverse of your transition matrix vector. Okay, the transition matrix, your columns are the basis vectors. Multiply the original by the inverse, just as we did over here, and you get 2, 5. And you could verify that. I don't think I did, but I think I did it just saying, okay, 2 times 1, 1 gives you 2, 2. 5 times 0, 1 gives you 0, 5. 2, 2 plus 0, 5 gives you 2, 7. The original vector again. So we have the same vector, the 2, 7 vector, represented with respect to basis script B, and then represented with respect to basis script B prime. Okay, this and this. Now I'm going to observe something. It's going to be useful when we try to go directly from this representation in terms of basis B to this representation in terms of basis B prime. How do we go directly from here to here? We could go from here to here by simply expressing this in its original form and then inverting that. But how could we do it directly? Okay, well, one important piece of the answer to that is if we multiply A times this vector, okay, well, that's going to be A times A inverse times your original vector. So A multiplied by your, and A being the matrix you see inverted here. When you multiply A by XB, you have to get this. Well, you're going to get this because X script B is A inverse times 2, 7. X script B is A inverse times your 2, 7. If you multiply that by the vector A, then you get the identity matrix, A times A inverse. Multiplying that by the 2, 7, you get the 2, 7. It's trivial. Okay, so if we understand that XB is A inverse times 2, 7, then it follows immediately that A times XB is 2, 7. And we check that to make sure it's true, and it is. Multiply the A matrix from this transition by the 3, 1 representation. We do get 2, 7. Okay, so in any case then, it follows that the representation of X with respect to B prime, which of course is A hat inverse times 2, 7, is just A hat inverse times A times XB. So that A hat inverse A is a transition matrix that takes you from B to B prime. So if you have the two bases, you could then form the A matrix and invert it, and the A hat matrix and invert it, and do A hat inverse times your A matrix. There's your transition matrix. There's a slick way to get there. Your text uses it, so I'll mention it. And there's a commutative diagram picture that I like much better here, and I might do that in another video, but we didn't have time. Okay. We can calculate A hat inverse A, like I just said. Here it is, and here it is. Okay? There's your transition matrix. It's a transition matrix. If you multiply this by this, you get this. Transitions from the B, script B representation to the script B prime representation. How do you get this a little more easily? Well, this matrix should take XB to XB prime, and we check to see that it really does. We just do the multiplication. Now, I just mentioned then this slick way to get this to work, to get this matrix without having to deal with two matrices. If you take A hat augmented by I and reduce the A hat to I, then the I reduces down to the inverse of A hat. Very familiar process from earlier in the course. So it follows that if you do A hat augmented by A and reduce that down to I, well, reducing A hat down to I gives you an A hat inverse over here. But if you start if you start with I, it gives you A hat inverse. If you start with matrix A, it gives you A hat inverse times A. And if you think about that, it's not too hard to understand how it works and why it works. So right here is the process your book gives you. It just tells you you take the, to do a transition from B to B prime, you take the A hat matrix, which is the matrix with respect to the B prime basis, augmented with the A matrix, reduce this to the identity, the A matrix reduces down to your transition matrix. Okay, so it's kind of a neat process. There's a lot more that can be said, and I'll probably say it later, but that should be enough to get you by at this point.